In section 3, multiplying powers with the same base. Really quickly, let's review the parts of a power. In yellow, I have highlighted base, and then the exponent is going to be a smaller number in the upper right-hand corner. So if you look at 3 to the 6th power, our base would be 3. In 5 squared, our base would be 5. And in 14 cubed, our base would be 14. And then the exponents would be 6, 2, and 3. You should already know the parts of a power, but that was just a quick review so that you know what I'm talking about when I say base and then what I'm talking about when I say exponent. I've gone ahead and made this table, and it asks you to go ahead and find a pattern. So in exponent form, in the first row, I have 2 to the first power times 2 to the first power. The next row, I have 2 to the first power times 2 squared. Then I have 2 squared times 2 squared, and so on. You can just kind of take a minute and look at this table, see if you can find a pattern. So when I have 2 to the first times 2 to the first, as a repeated factor is just written as a multiplication problem, it would be 2 times 2. If you take the numbers or the multiplication problems in the right column and you were to write those using just one exponent, the first row would be 2 squared. The second row would be 2 to the third power. Then we would have 2 to the fourth power, 2 to the fifth power, going down, 2 to the sixth power, and 2 to the seventh power. If you notice our original exponents, first of all of our bases are 2, but our original exponents, to get the new exponent from the repeated factor, we would actually be adding those two exponents in exponent form, and we could write it just using a single pattern. Or a single exponent, I'm sorry. In the table before, hopefully you saw the pattern, but it says to multiply powers with the same base, to multiply numbers or variables with the same base, add the exponents. So if I have a to the m times a to the n power, we could write that as a to the m plus n. So keep the base the same and add the exponents. If you look at this first example, it says what's each expression written as a single power? We have 9 to the 5th times 9 cubed. They have the same base 9, which is going to stay the same, and then we're going to add the exponents 5 plus 3 to give us 9 to the 8th power. The next example, we have negative 3 in parentheses to the negative 2nd power times negative 3 in parentheses again to the 10th power. Because there are parentheses around my negative 3, the base, I need to keep the parentheses around negative 3, and then I need to add negative 2 plus 10. Well, negative 2 plus 10 is a positive 8, so we would have negative 3 in parentheses. Make sure you keep the parentheses because they are in our original problem to the 8th power. This next example says what's the simplified form of each expression. For the first a, we have 6 times b cubed times 3b to the negative 8th power. Notice that now I have a constant in front of my variable and my power. What I'm going to do is I'm going to go ahead and I'm going to combine or multiply 6 times 3, and then I'm also going to be able to combine and multiply that by b cubed, and I can combine b cubed and b to the negative 8th, which would be b to the 3 plus negative 8. Go ahead and simplify what you can. 6 times 3 is 18, and then it would be times b to the negative 5th, because 3 plus negative 8 is negative 5. If you remember back to our very first lesson over exponents, I do not want a negative exponent. To turn a negative exponent into a positive exponent, I'm going to put it under 1. In this case, because it's being multiplied by 18, I'm going to put it under 18. So my final answer for A would be 18 over b to the positive 5th power. In question B, we have 4c times 3d to the 5th power times 2c to the 3rd power. Notice I have two different variables or two different bases going on right now. I have C's and then I have one D. I'm not going to be able to combine my C's and my D's, but I will be able to go ahead and combine all three of the constants in front of the numbers. First of all, C, the 4C, it would be to the first power. Remember, if there is no exponents, then it would be an understood exponent of 1. I'm going to go ahead and I'm going to multiply 4 times 3 times 2. And then I'm going to go ahead and combine my C's. So C to the first power, and then C to the times C to the third power would be C to the 1 plus third 3 power. And then I'm just going to leave my D to the fifth alone. There's nothing that I can combine it with because there are no like terms. Well, 4 times 3 times 2 is 24, times C to the fourth times D to the fifth. I have all positive exponents, so that's going to be my final answer. To multiply numbers in scientific notation, we're going to multiply the first numbers, and then we're going to combine 10 to a power using the power rules that we just talked about. Answers when you are multiplying two numbers in scientific notation need to be written in scientific notation. Remember, scientific notation, it's going to be a product. Your first number has to be greater than or equal to 1, but less than 10, and then it's always going to be multiplied by 10 to a power. If you look at this example, it says, what is the simplified form of 5 times 10 to the 6th, and then times 6 times 10 to the negative 10th? I'm going to go ahead and I'm going to combine my first numbers, or the 5 and the 6, and then I'm going to use my exponent rules to combine my 10 to the 6th times 10 to the negative 10th by adding the exponents. This will give me 30 times 10 to the negative 4th. But if you remember scientific notation, 30 will not work for my first number because it says this is not in scientific notation. To write it in scientific notation, write it in standard form and then back to the correct scientific notation. Remember, we only need that one number in front of the decimal. 30 would be greater than 10, so it's not going to work. Go ahead, and the negative 4 tells you to take the decimal where it is right now behind the 0, move it to the left 4 times. Go ahead and add in your zeros and your decimal. Then what you're going to need to do with that number is go ahead and put that number in scientific notation. We need the decimal behind the 3. We would need to move it 3 places, and we need a negative exponent, so it would be 3 times 10 to the negative third. Remember, you can tell if you need a negative exponent or a positive exponent depending on where your decimal is. In decimal 003, our decimal is in the front of the standard form, so our exponent has to be negative. If it's at the end of our number, when written in standard form, then our exponent would be positive. This next example says the speed of light is about 3 times 10 to the 8th meters per second. How far would a beam of light travel in 8.64 times 10 to the 4th seconds, or 1 day? I need to multiply these two values to figure out how far it would travel. Just like in the last example, I'm going to multiply my first numbers, and then I'm going to combine my 10 to a power by adding the exponents. Well, 3 times 8.64 is 25.92 times 10 to the 12th. Again, this is not in scientific notation. I'm going to go ahead and I'm going to take 25.92. I'm going to move the decimal to the left, to the right 12 times and fill in my zeros. This will give me the number written in standard form. So my decimal right now is at the end. I need the decimal between the 2 and the 5. So I'm going to count, and that would actually be 13 spaces that I would have to move. So my final answer would be 2.592 times 10 to the 13th power. Today's assignment is on page 458, numbers 1 through 7, and 8 through 50 even.